Hello everyone, welcome back to the another session on Principles of Programming Languages. We'll continue to learn about 5th unit. The next topic of 5th unit is about Haskell. So Haskell is a functional programming language. We were listed some languages under functional programming languages category. So functional programming languages category, we were listed Lisp is a language and Schema is a language, ML and Haskell. Fine. All four are under functional programming languages only. When you compare all four languages with each other, we say Haskell is the pure functional programming languages. The reason we say Haskell is the pure functional programming languages in the comparison. All four are functional languages. But when you compare each language with Haskell, Haskell stood for it as a exclusive functional programming languages. The reason is what we see in this video, but I wanted to tell you one point clearly. Whatever features we take from imperative, let's see some of the features are comparable with all the four languages. Let's say that variables. Variables we'll use in Lisp, we'll use in Schema, we won't use in ML, we'll not use in Haskell at all. So this is what the first comparison. And here Lisp is using a parameter. A variable can be used in Lisp as a parameter, functional parameter. And in ML also we'll use a parameter, but the value of the parameter will be given in the instruction itself. We don't take a variable declaration to say it is a variable. We won't have a separate data type and the variable to allocate the memory. We won't do all these kind of things as we were done for imperative languages. And coming to the other concept, which is of side effects of functions or else control statements. If you take control statements, we'll use in about 3 languages, but we'll not use in Haskell. So that's what the comparison we do have with all 4 languages. Basically all 4 are from functional programming. When you have a comparison in between of these 4, Haskell will stood for a exclusive functional programming languages. Now, so the same things you will come to understand from this video. Now let's look one by one the features of Haskell. So the best comparison of similarity in between Haskell and ML. Whatever we discussed in the previous video for ML, it is static scoped language, strongly typing language, all those are common parameters even for Haskell. Now, so Haskell is introduced by Thomson and in 1999. So it is a similar to ML. In which aspect it is similar to ML? It uses a similar syntax and it is a static scoped language and it is strongly typed language and it is having same type inferencing. In this 4 parameters, you can compare Haskell with the ML. So here you will be having a similarity. Haskell can be a similarized thing as your ML. You will be having these 4 similarities. We'll be even having a difference to show the difference. There are 3 characteristics of Haskell that set it apart from ML. These 3 characteristics are what we say, those are difference. Those are what similarities I say, these are what differences. Now, the first difference is what? Functions in Haskell can be overloaded and ML functions we don't have any overloading. Because in Haskell, we'll write a function name which is same from the other function name that I'll be showing with an example. So, but the concept is what? ML, Haskell have 4 similarities and 3 differences. The first difference is what? Overloading is the difference. And the second difference, non-strict semantics are used in Haskell, whereas in ML, strict semantics are used. Third difference, Haskell is a pure functional programming language. Now you have to understand why the reason I cannot call ML as a pure functional language. Yes, you can say even ML is a pure functional. But when you compare ML and Haskell, Haskell will stand for pure functional programming. The reason is what? It has no expressions or statements that have side effects, whereas ML allows some side effects for mutable arrays. With this difference, you cannot say the same feature of pure functional for ML. If you delete this feature from ML, ML can also be stand for it is a pure functional programming language. Now, and now there is a program which is to find out factorial of a given number and Fibonacci series. Consider the following definition of the factorial function which uses pattern matching on its parameters. So pattern matching we were seen in the ML also. The same feature is provided even in the Haskell. The pattern matching is what? Which is the pattern repeated? So fact is what? Your pattern. Fact is equal to 0 or else fact 0 equal to 1. Fact 1 is equal to 1. Fact n is equal to n into fact n minus 1. So using pattern matching, we can even define the computing the nth term of Fibonacci series. Fibonacci 0 equal to 1, Fibonacci 1 equal to 1, Fibonacci n plus 2 is equal to Fibonacci n plus 1 plus Fibonacci n. So this is the way how you have to compute Fibonacci nth term using pattern matching of Haskell. Now, very interestingly, Haskell programming language is having some similarities what we were find in recent programming language which is Python. The similarity is what? Look at this example 5:279. What it does is it includes the number whatever you are writing over here into the set of the list. Did you understand? Haskell includes a collection of list operations. For example, list can be concatenated with a double plus and colon. We'll use colon and double plus to concatenate the list. Look at the example 5:279. What the meaning of that? Colon is the operator which acts as a concatenated operator. 5 will get included over here. Fine. Now let's find. Double plus is also for concatenation. 135 is one list, 246 is the other list. Now concatenation is what? We'll put two different lists into together. The final list will be what? 135 and 246. That's what the concatenation. And serve as an infix version of the cons, and double dot is used to specify an arithmetic series. Now let's find out 1, 3 series operator 11. What does it mean? We'll take whatever series we missed over here, that all the series will return. So what the series we missed? 1, 3 or what? With the separation of two numbers, right? Or the differentiation of two numbers. The next number is what? 5. The next number is what? 7. The next is what? 9. So it is what? Arithmetic series operator. So these are what different operators what Haskell supports. And as with ML, list are written in brackets in Haskell as in colors equal to blue, green, red, yellow. These kind of similarity we were having even in ML. So one parameter can be having different kind of values. And you have three different operators what you did not find or else we did not find in the ML. So this is about Haskell. And a programming language is strict if it requires all actual parameters to be fully evaluated, which ensures that the value of function does not depend on the order in which the parameters are evaluated. So this is one of the feature of Haskell. So that's it. This is about Haskell. Thank you all.